Your goals may be clear, but there are often obstacles in the way. The shipping industry has to deal with new regulations, decarbonization, and complex fuel economics. At MAN Energy Solutions, we are dedicated to helping you find a clear route ahead. With us as a partner, you can face the future with ease. You can rely on a proven track record of millions of running hours. Our two-stroke dual-fuel engine portfolio offers full fuel flexibility and extensive retrofit capabilities with tried and tested performance. In short, future-proof propulsion without compromising on safety or reliability. As a reliable partner, our assistance goes far beyond the installation and commissioning of engines. We will support you throughout the whole engine lifecycle with our dedicated staff, our MAN PrimeServe worldwide after-sales service network. Clear route ahead with MAN B&W two-stroke solutions.
Hello, everybody, dear audience, and welcome to this MAN Energy Solutions Tech Talk on methanol-fueled engines. We are today broadcasting from Copenhagen in Denmark, and my name is Thomas Hansen, and I'm heading the promotion of our two-stroke engines. And with me today, I have my co-host in this session, Mr. Kjeld Arbo, who is our Director of New Technologies. We have an exciting agenda for you today. First, I will give you a brief market update a brief market update from the perspective of methanol engines. And then Kjeld Arbo will take over and give you an update on methanol as a marine fuel for propulsion, followed by a section on our Man B&W methanol engines, auxiliary systems, upgrade and retrofit market, and finally a summary. Following that, we will have a questions and answering session. The session today will be recorded, and questions are very, very welcome. It makes the session much better. The way you place your questions is by typing them in the box on your right-hand side, in the questions box, and then during the Q&A session, we will answer the questions. The questions which we cannot have not enough time to answer, they will be answered in writing afterwards. And all the questions will, of course, be treated anonymously. Very well, let's continue. So first, a market update from the perspective of methanol engines. But before we head off, just one more thing. I have 3 key takeaways which I would like you all to remember after today's session. The first one is that the technology, methanol-fueled two-stroke engines, it is ready, it is available. We have had 14 vessels in service powered by methanol since 2016. The solution can provide 100% carbon neutrality by the use of biomethanol or power-to-X-based methanol. And then thirdly, the solution is scalable. It means that you can start your operation on very low sulfur fuel oil and then gradually shift to methanol as it becomes available for you or as per your desire. Nevertheless, let's continue. 2021 was a year where methanol as a marine fuel really gained momentum. It was kicked off by the first order of a non-methanol carrier ship by Maersk, a 2,100 TEU container ship powered by our methanol engines. And following that, with their groundbreaking order of first 8 times 16,200 TEU container ships with our G95 methanol engines. Following that, in 2022, we have seen further order uptake for 4 more options for Maersk, as well as other orders. I will come back to that in a minute. But here are some of the headlines which we saw in 2021. Methanol as a marine fuel was really all over the medias, and lots of projects are looking into this now as we speak. It is not only container ships which is inquiring about methanol engines, even though they are at the moment the main drivers. It is also an increasing interest from bulk carrier segment, from tankers, ro-ros, and PCTCs. So in nearly all projects today, there are questions from the ship owners at some point regarding either methanol fuel from the outset or the possibilities for a methanol retrofit at a later stage. This is an overview over our dual fuel portfolio, our portfolio of different dual fuel technologies available. We have for methane the MEGI and MEGA engines. We have for ethane the MEGIE engines. We have for methanol the LGI-M engines, and for LPG the LGIP engines. And from 2024, we will also have an ammonia-powered engine. Today, we have more than 670 dual fuel engines on order or in service. So I think it is fair to say that we have really succeeded with our concept of future-proofing engines with the dual fuel options. This is an overview of the orders to date. As you can notice, the first orders on the lists are for methanol carriers and then chemical tankers, which can also carry methanol, so they can use their cargo as a fuel. And then halfway down the list, we see the order from Maersk Line for the 2,100 TEU container ship, and then later the big order for the 12 16,200 TEU container ships. We are very proud as of today to be able to present yet another very large order. It is from Singaporean express feeders who have placed an order for 1,170 TEU container ships with our S50 methanol burning engines. And we, of course, thank express feeders very much for this order. The interest we see as of today is really huge. All kinds of engine sizes are requested, and for all kinds of ship sizes. Due to this fantastic interest, we have actually decided to enhance our design plans for future methanol engines in our engine program. So we are proud to be able to announce that we have decided also to make an S60 version of our methanol engine, a G60 version, and a G70 version. The design schedules for the 60-bore versions is expected to be from the end of Q2 2024, of course subject to order. And this is an exciting news for all of you, And I know that many ship owners have really requested us to step into this segment as well. Our portfolio of methanol engines then more or less looks like this. The dotted lines, the areas here with dotted lines, they designate our existing methanol engines in our engine program. We have speed on the horizontal axis, and we have power on the vertical axis. We have the G95 powering the biggest container ships. We have the G80 10.6 powering, for instance, 7,000, 8,000 TEU container ships, but could also power large bulkers or very large crude oil carriers. Then we have in the smaller segment our 50 bore engines, both the S50 and the G50, and now the new decisions here to introduce the design plans for also G70, G60 and S60. And by that you can see that we are covering the whole range of necessary layout points for the ship designers to implement the methanol engines in nearly whatever ship type, as long as it is, you could say, from maybe 1,000 TEU container ships and up. Yes, so 2021, here are 5 things which really put the methanol as a fuel on the chart. Green methanol picked up as a marine fuel with the orders of the large container ships I mentioned before. More than 32% of all contracted ships in 2021 were actually with dual fuel engines. So this is really a shift in the ordering. Large-scale conversion projects from conventional fuel to alternate fuels, it proved that our Man B&W engines, the NEC engines, they are future-proof and can be converted in the future into any of our dual fuel technologies. And then finally, environment, regulatory compliance and public awareness and green transition after the COP26 is really pushing for dual fuel contracting. So all in all, really exciting times. Methanol can be a solution which is ready and available here and now. So following this, I will hand over the microphone to my co-host, Kjell Arbo, who will take you through methanol as a marine fuel for propulsion. Please, Kjell, the floor is yours.
Thank you very much, Thomas, and also hi from me. So, ladies and gentlemen, I will continue here and speak about methanol as marine fuel for propulsion. As Thomas mentioned, also the output from the engine is the same as the efficiency if you compare with our single fuel oil operating engines, about 50 to 55%, depending on what load where you are operating. If we look at the emissions and look first of all on the methanol which is today, then we will see that compared to heavy fuel oil, we will have a reduction of 30 to 50% in NOx, 90 to 97% in SOx, 90% in particulates, and 10% in CO2. If we consider to have a green methanol or biomethanol used, then it will be 90 to 95%. The rest will be for the pilot oil. And if we consider for the future, and that I think is very exciting also, to use biofuel as pilot oil, then actually we will have 100% CO2 neutral engines. So if we look at the main advantages of methanol as a marine fuel for large merchant vessels, we have already proven the engine design in 120,000 running hours. We also have a user forum where we have feedback, and from the first engine on the water with methanol operating engine in 2016, we have every year held such a forum with feedback from operators in order for us to optimize the design and the best solution for the operators. Global natural or carbon neutral green methanol can be used, of course, and give a carbon neutral output or emission. It's easy to store. I'll come back to that on the fuel gas supply system. And it's a very simple fuel gas supply system, especially if you compare it with the organic system, which is for LNG and ethane. We made together with Hyundai, DNV, and Methanol Institute a small study not that long time ago. And we said to the yard, could you please make a calculation for the pricing on a vessel, which is operated on single fuel oil, and one if it was methanol operated, and one if it was LNG operated. And if we take index 100 for the diesel operated engine, the single fuel engine, then we'll have index 100. If we take it for the methanol, it will be 110. And if we take it for the LNG fueled engine, it will be, the vessel price will be 122. So you see there is quite a difference when we compare these OPEX for the different fuels to be used. And here, as I mentioned, we have the carbon neutral, the easy storage, and simple fuel gas supply system, and I will come back to that part also. About scalability in this energy transition, we will have for a long time a transient period of time where there will be some green methanol available, but it will take time before it will be available in full scale. And in that time, we are able on the methanol engine to operate in this, you can say, with increasing amount of methanol drop in, and for whatever is available out there, and for commercial and still is commercial attractive. As also mentioned by Thomas, we see a huge interest out there for being green, to go decarbonizing, but not only for ship owners, but also for charters and end users. And that is very important also to move this in the right direction for decarbonization of the maritime world. If we look at the timeline, I can mention that in the 80s, and I was in the company also at that time, in the 80s, we actually designed the diesel cycle GI, gas injection engine. It was at that time for a mechanical engine, and it was primarily to be used for LNG carriers. That was the idea from the beginning. And then later on, of course, also other vessels. We were also at that time looking at the diesel cycle versus the Otto cycle. And the diesel cycle have quite a lot of advantages when it comes to the LNG part. But in general, the decision was made because then we could have so many different type of fuels using this principle, still with the same efficiency and power output. So that was the primary reason for choosing the diesel cycle at that time. LNG was the first one we got the order for. Later on, it was methanol. And when we develop an engine for methanol, we make a lot of testing, of course. First of all, in our research center here in Copenhagen. Later on, we made also together with Mitsui and then Hyundai, also had testing. And then in 2016, we had the first sea trial with this one. Then we developed Tier 3 compliance with water. So we reach Tier 3 NOx and X6 by adding water to the methanol, like gin and tonic, you could say. And and you, as I mentioned before, we have 30 to 50% less NOx compared to the heavy fuel oil, or also very low sulfur fuel oil, and that means also it's limited amount of water we have to put in. Then we had NOx certification here with the W here, and that is with the water injection. It is so that not all the engines in our portfolio, the LGIM methanol engines, not all of them are available with water blending into the methanol for tier 3. Then other solutions should be utilized, like exhaust gas recirculation. And then 2021, you have already heard that from Thomas, when A.P. Møller Maersk, they started up and ordering for their container vessels. Then suddenly the market opened up. Fantastic. It was really huge. And as Thomas also mentioned, we are speaking with so many interested parties in the world. Not only, you could say, ship owners. Now it's also banks, but it's also outside that. It's also investment companies who would like to know what is the possibility that there will be a huge market for green methanol for the marine engines. And here we see, as also mentioned by Thomas, these 12 times 16,200 tow container vessels. Just for a comparison, if you think about it, how much consumption will there be for such a vessel? And if we take it about 50% load and operating 270 days a year, we talk about 44,280 tons methanol per year. If we look at the smallest one, the first ordered container vessel on 2,100 tow, then we talk about 10,881 tons per year for the same conditions, 50% load. In order to also look into the logistics, Maersk have already made, with a consortium of companies, made it possible to actually get the green methanol and starting up from 2023 to 2030, and it's based on sea windmills or windmills at sea. Looking at the engine itself, the methanol engine, it is, as mentioned before, it's a simple, very simple fuel gas supply system we have. We need a system that can boost up the pressure to 13 bar. Then the methanol goes into the injection part on the engine itself, where it's further boosted up to 600 bar before the injection. We utilize 5% of energy fraction with a compliant fuel. You know, biofuel is actually not compliant for the time being due to NOx levels, and IMO is looking very much into this, as Ajax also just forwarded a suggestion how to do and so on. So we are sure that something will happen there. We are also going to make some testing here ourselves. So operation on methanol from 10 to 100%. Regarding lube oil, cylinder lube oil, and so on, we utilize the same lube oils, 40 BN with a high detergency, as we also do for other low sulfur fuels. So if we look into the system itself, we have here below, we see the double wall piping. In the double wall piping, we have between the inner part and the outer pipe, we have hydrocarbon sensors. So if there is a leakage, this will be detected. There is a continuous ventilation between the inner and outer pipe. And if a leakage will be there, it will be transported to these and will be passing the hydrocarbon sensors. And immediately there will be the safety valve in the fuel valve train will shut off the supply of methanol, and the engine will automatically change over and operate on normal fuel oil. If we look at the methanol supply, this is made inside the cover itself. We don't have methanol in a pipeline here, single pipeline, which could break if something falls down on it and so on. So this is protected for safety in the system here. We have the total control block here, and we have also on this side, we have the hydraulic oil. The hydraulic oil is there for controlling and boosting up the pressure. So we're boosting in, you can say, the methanol to the 600 bar. We also have a hydraulic accumulator who secures a proper power and proper pressure in the system, a constant pressure in the system. We have a fuel bowl injection valve for methanol, and that's actually here inside where it's both a booster pump, that was the 13 to 600 bar, and then we have a valve and we have the nozzle itself. We have, the lubricity in methanol is very, very little, or you can say quite opposite, having a lubricity, and therefore between the plunger and barrel in the fuel pump, methanol pump, we have a special coating. Then we have a sealing oil, and that is where hydraulic oil can potentially be mixed with methanol. Then we have the sealing oil added in these special points in order to minimize that. We have the control valves down here, and you see all where it's located here on the engine itself. Are we looking at the auxiliary systems? Yeah, then we take it and you can say make it in 4 or 5 different parts: service tank, fuel valve train, the ventilation itself, the nitrogen purging, and the low flash point fuel supply system. Before an engine is finally designed, such a fuel gas supply system is also to be designed, of course. We need it also for the first test we are doing on, in this case, methanol. And there is a huge work before such a system is designed. We make hazard investigations together with classification societies and ship owners and shipyards, and also suppliers, as for instance, such a fuel supply system, all due to safety. And in this case, we are speaking about a low flashpoint fuel, which was not part of the IGC or IGF codes at that time. And actually, it came in those codes and regulation only 1 year ago, where it was introduced, and that means much later than the first engine what was a sea trial on methanol. The reason for that was accepted still to operate on methanol was because ship owners got the acceptance from the flag state, and of course based on these hazard investigations that have been going on. If we look at the service tank itself, we will come a little bit back to that, so I will not cover that here. I will just say that also normal fuel oil tanks can be used if they have a proper coating. We have normally a split in 2 compartments in such a tank. Fuel valve train, yeah, here we have the master valve. That was the one where you can block and stop for any supply of methanol into the double wall piping, which starts when the methanol pipes are entering into the engine room. We also have in this unit the purging of the nitrogen, so we are able to purge all the pipelines on the engine if something should happen. Because being this low flashpoint fuel, a number of operation scenarios call actually for a clean pipeline. So what we do here is to enter the nitrogen and when we are purging and pushing out, you can say, the methanol. We have the low flashpoint fuel supply system, and also here we have to prepare that in parallel with developing the engine on methanol, where we ensure that there are companies out there who can supply such a system, also with high reliability and availability, and of course the safety issues. Nitrogen purging. See, if we look a little bit into the tank, the tank for if we look a little bit into the fuel gas supply system, here we see the different parts we talked about. We have the tank, we have supply, we have a low pressure pump, we have a high pressure pump, and we have heaters, we have filtration, and then we have the fuel valve train, which also, you can say, have a bypass back to the tank. And we have the nitrogen coming in here for the purging. We talked about the ventilation of air outlet here, also where the hydrocarbon sensors is located in case there should be any leakage that will register, that will feel that, and it will of course turn off the supply of methanol. Here we have the tank itself. I will not go too much in detail with that, but it is main purpose is of course to store the methanol, but also prevent contamination of cargo and storage tank if you, for instance, are using the methanol engine on a methanol carrier. And it separates the supply of methanol in fuel compartment from return contaminated methanol with sealing oil. You remember the sealing oil on the top of the engine itself, and nitrogen in the return compartment where we have your nitrogen from the purging part. Then we look a little bit into upgrades, and we call it upgrades because it is only a top of the engine, and you can see here the yellow part. It is and it's very important to understand, it is like a diesel. It's a diesel engine, diesel cycle. It is like our normal fuel oil burning engines, but it has this module added on, and in this case, it is for methanol. And if we look at possibilities to make these upgrades, then we can upgrade an MEC engines for the different type of fuels. You can also imagine if you, for instance, have an LNG engine today, and in 10 years' time, ammonia will be available to the right price and without the carbon, then you can actually also go and have your MEGI engine upgraded to operate on ammonia. At this time, we have actually upgraded following engines. We have one on ethane from MEC engines, the fully controlled engine, to an ethane engine, 3 for GI, for gas, LNG, and then we have 12 almost. We are in still operating or in process of making the last 3 of a series of 15, which was MEC engines converted to LGIP, the propane engine. And we see a huge market for such an upgrade in the future. We talk about EECI, CII, and all the things that have an influence on, you can say, the efficiency itself and the pollution or the emission from the exhaust gas. If what we see also here is many ship owners, they go out, order ships which is prepared for a future fuel or future dual fuel as methanol. The main engine itself, as Thomas also mentioned, it is future-proof. That means we don't go and make any preparation on the engine itself. And that will also not be that wise because you don't know what fuels will be the future fuel for your vessel, and you should be able to convert to whatever will give you the best business case. So we upgrade ability for future possibilities. That is our standard MEC engine. Tank system, fuel flexibility, endurance, and so on have to be prepared on the vessel, and that means that there is a dialogue between the engine or vessel designer and the yards and so forth, and the system suppliers and so on, and what can we do? So everything on beforehand is actually prepared. Only a space and strengthen, you can say, the construction to be able to have tanks, for instance, on deck and so on. This is considered already. And that we see in a lot of projects. Is also included in the design here with the hull structure and reinforcement and so on. If we look at machinery space, bunker stations, fuel supply systems, fuel valve train, hazard areas classification, and windmast arrangement prepares and so on. Also, this have to be considered when you can say you prepare your vessel for future fuels. We have made a press release from the 28th of January this year regarding the dual fuel retrofits of low-speed engines, and that you can get, of course. We also have you can say, separate paper about utilizing methanol in our engines. We can also advise about the fuel gas supply system and so on. And you're, of course, very, very welcome to come back to that. But we have about 22,000 of our MAN B&W two-stroke engines is operating out there today. And about 3,500 are fully electronic control, like the MEC engines. And that have a potential for the conversion, of course, for these green fuels. It's further evaluated that approximately 2,300 or so of these vessels are appropriate candidates for actually making this upgrading, resulting in savings as much as 86 million tons of CO2 emission annually. That is a big number, we could say. We also have, just a minute. We also are from MAN Energy Solution engaged in a project in Chile. We are here speaking about production of synthetic fuels. Porsche, which is also part of Volkswagen, is initiator on this. It goes for a methanol reactor for highly innovative fuels. Innovative fuels. And the goal is that here it should produce about 55 million liters in 2022 and 550 million liters in 2026. So, and also based on wind electrolyzers, which our company, MAN Energy Solution, actually also are part of such a supplier of electrolyzers. And based on, the electrolyzing, where you split the hydrogen from the O from water, and you filtrate the CO2 from the air, and you combine this, you can say, for the oxygen and the hydrogen to the methanol. So a small summary, ladies and gentlemen. We expect the uptake of methanol as a marine fuel to increase significantly. The proven MAN B&W ME Lgim engines are available today for a wide range of vessels, as you saw from the layout of Thomas's for the different engines. And the proven engines are available, and the engines can be fueled with very low sulfur fuel oil until green methanol is available at scale or at, you can say, on attractive prices and so on. Relatively simple auxiliary systems means that conversion to ME Lgim is attractive. Huge demand for green methanol provide positive outlook for the supply of green methanol in the future. And we see a huge interest also to invest in such. So the whole, you can say, distribution, production and distribution line and so on also will work in the near future. Thank you very much. And back to you, Thomas.
Yes, thank you very much, Kjeld. And now we are ready for the Q&A session after this very exciting presentation by Kjeld Arabo. And dear audience, you have been so kind to bless us with a lot of questions, and that is just wonderful. We like that a lot. So the first one here I can read out is, which shipyard countries show interest in your two-stroke methanol engines? And I think I can answer that quite easily. It is the three major shipyard countries, China, South Korea, and Japan. They are all showing very large interest in the methanol engines, all across different ship types and bore sizes. The next one is, while green methanol can be carbon neutral on a life cycle basis, what are the tank-to-wake emission reductions compared to MGO or diesel and very low sulfur fuel oil? Do you want to take
Yeah, I think actually I mentioned it in presentation,
Yes.
but I think it's so much reduction that it's worthwhile also mentioning it again for sure. It will be around 10% reduction in CO2. This is something which is established and concluded by IMO, and also the figure that we are using. It's a little bit different if it's MGO and diesel, or it's very low sulfur fuel oil. You could say 9% for MGO and 11% compared to very low sulfur fuel oil in reduction. So what also was mentioned both by you, Thomas, and myself was that this advantage with this dual fuel methanol vessels and the engine is that you can make the drop in. It's easy to increase the drop in of green methanol over time. So you can be more and more green, you could say, depending on what is available and what gives a good business case.
Exactly. It's a scalable solution. Exactly.
Yes.
Then another good question, which we actually get very often. What are the main benefits of methanol compared to ammonia? And do you want to start off, Kjeld?
I can do that. Of course, the business case, we don't know. We don't know what will be most attractive in the long run. We do believe that there will be more different type of fuels. We believe that there will be e-LNG, and there will be e-methanol, and there will be e-ammonia, and so forth in the future. There will also be the biofuels, biomethanol, and so on. So there will be many there. So if you look at the differences, you could say we do expect that on the engine side itself, it will be more or less the same components that we will see. But we have not tested the ammonia yet, and this is to be seen in 22 and beginning of 2023, where we have the final design. So the expectation is that when you have a fuel gas supply system for ammonia, then you have about 33 degrees minus for having it liquid. If you look at the methanol, you can have it at normal atmospheric pressure. You have it in a tank, and it's so simple compared to cryogenic systems and so forth. So there will be definitely a difference in price for the two, you can say, different fuels. Both of them have a relatively low calorific value. compared to fuel oil and gas and LNG and so on. That means also that the tank have to be relatively bigger if you are designing for the same route or transportation.
Yes.
Otherwise, I would see it's also quite simple on the ammonia, except for the tank itself. But yeah, sorry.
Yeah, no, but thank you, Kjeld. But I think I would also like to add that the big difference is that another big difference is that today the methanol technology is very well proven. We have more than 120,000 operating hours on vessels in service with methanol fueled engines. So it means that all the teething problems, they are long gone cured. And it means that now we have a completely ready technology developed, which we can do the detailed design of for the different bore sizes relatively quickly and run them into the market relatively quickly, like we have done with all the other dual fuel types, which we showed you in the presentation. There we also started out with one bore size. We had, of course, like you always have, some teething problems. And then when the design was stable and proven, we have expanded it with ease, and we are very good at that due to our modular design philosophy into a lot of other bore sizes. So the big thing here is also that ammonia engines, yes, it's under development and it's in good progress. We are on schedule. First engine will be delivered to a shipyard in the end of 2024, but methanol engines, they are here. The technology is ready. If you want to decarbonize today, this is a good possibility. Alrighty. With the increase in the two-stroke methanol engine market, how many of your engine builders are looking into manufacturing methanol fueled engines? I think I would like to start off because it's quite easy. It is practically all. You could say the bigger ones will most likely be the front runners, but all the engine builders are looking into that now and taking methanol as a fuel very seriously and looking at investment plans and so on to be able to deliver methanol engines. So I think that what you can do is that you can ask the shipyards when you ask for a methanol fuel ship to have different engine suppliers listed in the offering. Alrighty, what is the optimum water content in used methanol? Respective, do you prefer your engines with some specific water content in the methanol, or better, for instance, 99.9% purity? Do you want to take a crack at that?
I'm not sure if I remember correctly, but I think we in our specification says maximum 0.2% of water. But this is based on what we expect of methanol to be out there. As also mentioned, we have engines operating with water mixed into the methanol, and that in itself is much larger amounts. So I would say it's if you have a question regarding a special methanol, then send it to us and we will comment on that.
Yeah. So in fact, what you are saying is that yes, we have a specification, but yes, we can adapt the engines to run on the available fuels.
Yes.
So that is in reality not a problem. Compared to LNG as fuel, can you give the percentage of capex gap in if the ship is using methanol as fuel? And Kjeld, I think there was a recent case where this was actually discussed.
Yeah, as mentioned, we looked at it together with Hyundai and also Methanol Institute and also DNV. Yeah. And this study we made, you had 3 situations for the same vessel. One was burning fuel oil, normal single fuel. The other was burning methanol, and the last one was burning LNG. And the capex cost difference was that if you put a normal single fuel as index 100, then it would be 110 for the methanol burning engine, and it will be 122 for the LNG burning engine. And this is for a 54,000 cubic meter tanker. Of course, that is different if you go in larger scale, then the percentage of the dual fuel part will be different, but it is relatively more expensive with the cryogenic systems.
I think also that we can say that in general, we have, as an engine designer, to be very, very careful when we talk about pricing of ships, because that is really outside our territory. So you can only, dear audience, take this as very rough indications. Yeah. Shipyards are the real experts here, and they can provide you with the exact prices, right? Yeah. So, but it's a good indication. LNG will comparatively be more cost compared to methanol. Then, thank you for the webinar. I'm curious about the market outlook of dual fuel engines. What is your feeling about order intake in the coming years? And are the suppliers able to supply spare parts to meet the demand? We are, of course, looking into the crystal ball to try to figure out what will the fuel mix of the future be. And frankly speaking, we have had to revise our predictions a number of times, and we're actually doing it right now again, because the order uptake in 2021 of 32% dual fuel engines, that was groundbreaking. So it has led us to increase our prediction, increase the share of dual fuel ordering. So our previous estimation said that in 2030 we would be around 60% of all ships contracted, but it may be even more. It may go even faster. We really think that it is all, of course, depending on many things, legislation, so on, fuel prices, and also customer demands. From the end consumer, but everything looks in the direction that the order uptake is really going to accelerate now more than we have actually expected before. But difficult to give a clear answer. I hope for your understanding on that. Yes, then there's one more here. Does the addition of water to the fuel mixture require the engine crank and connecting rod materials to be engineered more robustly? Any residual water at lower temperatures are incompressible and can increase stresses significantly, perhaps? And here the very easy answer is no. When the engine, both the LGIM engine, which uses a tier 3 technology like SCR EGR, or the methanol engines which use water as a tier 3 technology, as long as you are within our specifications, there's no need for additional material strength in the rotating masses and components. Yeah. Then here, could you please advise if retrofit of an LGIP engine to LGIM, that is methanol, is possible? And maybe Kjeld, you could take a crack at that.
If it's a MEC engine, as we also talked about, then it is possible to retrofit. Technically, it's possible, yes.
Yeah. And I would also add to that many customers, they ask us, if I want to prepare in the best possible way to future-proof my investment, I'm not ready to go for methanol today, but should I then buy an LGIP engine which can run on LPG or an LNG engine, that is an MEGI engine, would that be less or more cost efficient to convert it into methanol at a later stage? And our answer is always the same. No, actually not. Because even though some of these dual fuel technologies share the basic development and the basic engineering, then the sizes and the packing materials and so on are different. So bottom line is that as long as your engine is of the MEC engine type or generation, then it is retrofittable and cannot be made more retrofittable by having the outset as an LPG engine. Most important is that the ship is ready for the conversion. So, hello, is the slide deck available after the webinar for download? And here the answer is very easy. And Kjeld, do you want to do it?
Yes. It's available. It will be got available. Yes.
Yes, exactly. And then another one here. Do you have to inert the fuel tank? And I can take a crack at that. The answer is that yes, the fuel tank has to be inerted, and classification societies, they have technical papers where detailed information about this is described. And it's better that you consult these to get the exact information from your classification society. Alrighty, there are many questions and not so much time, only 4 minutes left. So it may be one good one here, Kjeld, for you. Many thanks for your nice presentation. Can you provide some more information regarding cylinder lubrication for methanol fueled engines?
Yes, we can do that. We have for low sulfur fuels, we have a guideline, we have service letters and so on, and we can easily send that out with a link. So and please come to us if you need more information. We also have, of course, observations from the LGIM engines in service, cylinder conditions, and so on, and that we can also discuss with you directly. But so far, it goes very well on the engines.
Okay, look. Then another good one here for you, Kjeld, is dear Kjeld. Even it says, in case of an oil spill, what is the risk for the marine environment since methanol is regarded as biodegradable?
Yeah,
so it means not oil, but a methanol spill.
Yeah, methanol, yes, but it is, yeah, exactly, and you can say the hazard in itself is very, very limited when that happens with methanol spill. There is, of course, regulations, and again, the classification societies know how to do and avoid such leakages and spills.
Yes, there's also another good one here. It is, thank you for today's webinar. I want to know how many methanol fuel conversion projects is ongoing. And I think I can answer that. And now correct me if I'm wrong, Kjeld. But as far as I know, none.
Yeah.
Because the interest is picking up. But I know from our retrofit department, retrofit and conversions and upgrade department, that they are getting an enormous amount of retrofit requests now, and are doing a lot of business cases for ship owners for methanol engine conversions. Many prominent ship owners are asking for that, both big and small. And so there's a lot of action going on here because it is very attractive for retrofit due to the cost effectiveness of that solution. And as I said it many times, I would like to say it again, all our MEC engines are future-proof and retrofittable into our dual fuel technologies. Also, even if that technology does not exist, or not technology, but that size or exact variant does not exist in our current new sales catalog, it doesn't mean that we cannot apply and make the detailed design for a retrofit case. So come to us with your retrofit cases and we will advise you and look at them. Thank you. Anyway, I think now we have to wrap up because there's less than 1 minute left and we do not want to exceed the time which we have already used from you, dear audience, and we are very grateful that so many participated and chose to use their time together with us. So, yes, final word from me here, the 3 things I wanted you to remember. The technology is ready and it is here. It can be completely greenhouse gas neutral if you use power-to-X fuels or biomethanol, and it is a scalable solution. And then over to you, Kjeld, for a final closing remark.
Yes, thank you very much for listening in, and we hope to see you next time we have a webinar.
Thank you very much, all. Bye-bye.